So slope, constant rate of change, we see this in linear functions, and we find the slope by taking the difference in y over the difference in x. If you have two clearly labeled points, what I always do is I just label each of these. So I label my first x1, y1, and I label my second x2, y2. The ones go together for the first point, the twos go together for the second point, and then you just plug them in to your formula. So y2 is 5 minus -4, which is our y1. And then x2 is 4 minus -3, which is our x1. Then we change the signs, right? Negative, negative becomes plus. So the slope of this line is 9/7. Okay, and that's the constant rate of change. That's how this linear function is changing the entire way throughout its domain. But if we don't have a linear function, we can still find the average rate of change. We just don't call it the slope. We call it the average rate of change between 2 points by finding the slope of the line that connects them. So for example, if you have this is, for example, a quadratic does not have a slope. But if we wanted to find what the function is doing between, for example, these 2 points, we would find the slope of the line that passes through both of those points. And that slope would give us the average rate of change over that part of the domain of the function, okay? So there's a few different ways that we'll find average rate of change. First one is by using a graph. So like this example, or like when we are just doing slope, we can also use a graph. With a graph, you want to choose 2 points, or if you're specifically given points, that you can clearly see. So in this one, they say find the average rate of change over the interval -2, 1. Notice the closed brackets. That means those points are included. That's where they want us to start. And these are both x values. Because we're talking about domain, interval notation. So from -2, when x is -2, which will be here. So -2, this is -2, 4. 2, when x is +1. So this is at 1, 1. So those are 2 x values that they're going to give you to guide where you're finding your average rate of change. Then we're going to find the slope of this line that connects these 2 points that we were given, and that will be our average rate of change. So we're going to take slope formula. Okay, so I always start, like I said, I always label these just so that I don't mess anything up. I'm going to call this x1, y1, and I'm going to call this x2, y2. And then it's super easy just to plug them into our formula. So y2 is 1 minus 4. Y2 is 4. Or sorry, y1 is 4. And then x2 is 1 minus x1, -2. Those become pluses. 1 minus 4 is -3. 1 plus 2 is +3. So the average rate of change over that given interval is -1. It's always super nice when we have the graph. That makes things a little bit easier, but what we see a lot is that we don't often have the graph. So we need to know how to find the average rate of change without the graph. So for example, well, here's the directions. It says plug in each x value to get a corresponding y value. So they're always going to give you 2 x values to indicate the interval, and then you need to plug each in to get the y value that goes with that x, and then you just plug it into your slope formula. For example, number 2 says find the average rate of change on the given interval of f of x equals -x to the third plus 3x. And then letter A wants us to find it over this interval from -2 to -1. So remember, these are x values. We'll call this x1 and x2. Then we want to find our y values that correspond to each of these. So we're going to take x1 and plug it into our original, and that's going to give us y1. So -1 cubed plus 3 times -1. Be careful of your order of operations. You must do this first. So -1 cubed is -1. with the negative out in front. Yes.
Switched
What did I switch?
x1 and x2.
Oh, you're right, because I'm doing x2. Let's just call this y2. Thank you. You are right. This should be y2 because I'm plugging in my x2. So then we get 1 minus 3, which is negative 2. So y2 is negative 2, and now let me do it the right way and plug in for y1. So I'll plug in negative 2, negative 2 to the third, plus 3 times negative 2. Yes. So then negative 2 cubed is negative 8, plus the other negative sign gives us positive 8 minus 6, which is 2. So y1 is 2. Now that we have all of our values, we just plug in to find that average rate of change. So y2 is negative 2 minus y1, which is 2. And then x2 is negative 1 minus x1, which is negative 2. So we get negative 4 over, what did I do?
Wouldn't negative 2 cubed be negative 8?
Yes. And then there's the negative out in front.
Oh, I didn't see that.
So then it comes negative, negative, which is positive. Yep. And then negative 2, or negative 1 plus 2 is 1. So the average rate of change over this interval on this particular function is negative 4. All right. Let's do this one. Okay, again, this is going to be two x values. This is an x1 and an x2. So we'll find our corresponding y values. Yeah, go. y1 is going to equal when we plug in 0. So 0 cubed plus 3 times 0 is going to just give us 0. Yeah. So then y2 would be when we plug in positive 1. So negative 1 cubed plus 3 times 1 gives us negative 1 plus 3, which is 2. So y2 is 2. Last step, just plug it in. y2 minus y1 over x2 minus x1. So just 2 over 1, which is positive 2. Okay. You will see fractions, and as we know, I expect you to be able to work with the fractions if you see them, so to use your fraction rules. So this one says find the average rate of change on f of x equals x minus 3 over x on the interval 5, 12. So this is x1, this is x2, and then we'll find y1 by plugging in 5 to the given equation. So 5 minus 3 over 5. Which is 2/5. So y1 equals 2/5. Okay, so then y2 we'll plug in 12. So 12 minus 3 over 12, which is 9 over 12. And simplify, 3 over 4. So y2 is 3 over 4. And then we have to plug it in, and we're going to have to work with our fractions. So y2 is 3/4 minus y1, which is 2/5, over x2, 12 minus x1, 5. So in order to do that subtraction on the top, we need to get a common denominator, which would be 20, right? So 4 times 5 is 20, 3 times 5 is 15. Minus 5 times 4 is 20, 2 times 4 is 8. So 15 minus 8, we get 7 over 20 over 7. You cannot leave what we call a complex fraction. You can't have a fraction within a fraction. But remember that this big fraction bar means divide. So what we can do here is take 7 over 20 divided by 7 over 1. And remember, when we are dividing fractions, we copy, dot, flip. And then we can cancel the 7s so that we get 1 over 20. Over the interval -3 to 8. So what we need to do is find -3 on this graph, which is down here. So that's at -3, -90. Be careful of your intervals. They're going by 20 on the y-axis. And then to +8, which is here. So this is 8, 20. So then if I label x1, y1, x2, y2, find my average rate of change. 20 minus -90 over 8 minus -3. These become plus 110 over 9, 10, 11, which is just 10. Okay? Okay. These are what your delta will look like. Hold on, I need to change all these values because they are wrong. So if we check the rate of change between 4 and 6, this is our x1, this is our y1, and then not our y1, that's our x2. Because these are both x's. And then y1 is going to be 7, and y2 is going to be 13. So then we'll just run our little formula, 13 minus 7 over 6 minus 4. 6? No. 13, what's 13 minus 7? 6, yeah. 6 over 2. So this one is 3. Then we'll look at 614. So we compare the y1 and y2. And then do our average rate of change. So we get 10 over 8, which is 5 over 4. Okay, so far, which one's smaller? 5/4 is smaller. So we can get rid of A because we know that 5/4 is the smaller one now. If we look at C, from 14 to 33, so those two values are 23 and 34. 34 minus 23 over 33 minus 14. So 11, this becomes 11 over -19. Which one's smaller?
Would you still have minus over 19? Over positive?
Wait, what?
Would you over positive 19?
Yeah, you're right. It is positive 19 because it's not.
That's smaller than front.
Yeah, so that is smaller than 5/4. So we're going to cross this out. And then our last one will just be comparing D, C, and D. So 33 and 55 would be 34 and 40. 40 minus 34, 55 minus 33. So we get 6 over 22, which is the same as 3 over 11. If you put these in your calculator, you can get the answer. This one's -0.579, and this is 0.027. So which one is smallest? This one. Okay? So that can be helpful to compare the decimals because it is harder to compare fractions just by looking at them. Okay, you will be asked questions like this as well. It says a function is graphed below on which interval of x is the average rate of change the greatest. When you can visualize it, the greatest average rate of change will be the one that is going up the fastest. So we can see which one this is. If you're not sure, you have ordered pairs and you can always plug it into your slope formula. But the one that's rising fastest has the greatest rate of change. The one that's rising slowest has the least rate of change. So for this one, which interval is our average rate of change the greatest? A, from 0 to 3, because it is rising the fastest, and we can visually see that. Yes.
So we can just look at it, we don't even have to do.
You can look at it as long as it's really clear that that is the fastest. If it's close, then you need to check. If it's something that you can't clearly see, then you have to label. So you'd have to be like, okay, I'm going to call this x1, y1. I'm going to call this x2, y2, and I'm going to find the exact rate of change over that interval and compare it to the others. Okay. Okay, last up, I just want you to see this because some of the delta will give you intervals like this. So sometimes they give us them in interval notation, sometimes they give us them in inequality notation. So remember, just for review, that this is the same thing as 0, 4 in brackets. And so if we were doing this, this would be our x1, this would be our x2, and then we can find the corresponding y's looking at the table. So this would be our y1, and this would be our y2, because that's what correspond with 0 and 4. So then to find our average rate of change, we would say y2 minus y1 over x2 minus x1. So 45 over 4. And that doesn't simplify any further. So that would be our average rate of change. Okay? So just know that like that inequality notation will show up as well, but it means the same thing.